I'll also open up this text editor right here. So this has all the instructions I'll be going over to copy over the code that Michael was running. So the first thing I want to do is to navigate to the BP22 game dev starter directory. So this is if you got the git clone to work last time. If you didn't get git clone to work last time, don't worry. We have something planned for you. You can install GitHub Desktop, which is an alternative way to use Git. It is also linked on slide 10 over here. So if you weren't able to get git clone to work in your terminal, like we did in the first workshop, you can also use GitHub Desktop, and I'll run through that right after I go over the terminal instructions. So for the terminal instructions, the first thing you want to do again is to navigate to wherever you had your game dev starter folder. So in my computer, I like to keep all my coding projects in this folder called workspace. So in workspace, I'm going to change directory to workspace, and then I'm going to change directory to BP22 game dev dash starter. Okay, so now that I'm here, I can run this command. This will only work on Mac, so don't worry if this breaks on Windows. Now that I'm at this current directory, I'm going to type in git branch to test which branch I'm on in Git. So if this command doesn't work, you're probably having issues with your Git command line. So I'd recommend using GitHub Desktop. And if it does work, we can continue on to the next command line step, which is to change your branch. So right now you can see I'm on the 00 initial game branch. So this is the branch that me and Kosi made to start the repository. So this is just like the base layer of the game with nothing loaded in. In Michael's workshop, he went through branch number 1, animating the player. Branch number 1, adding the background, and branch number 2, moving the player. So for Kosi's next upcoming section, we want to be on branch 3, animating the player. So the way you move branches in Git is through a command called git checkout. So we're going to run git checkout force 03 animating the player. And I'll send all of these instructions in the chat too, just so you guys don't have to type racer me. Yep. So I'm going to run git checkout f 03 animating the player, and it should say you switch branches to 03 animating the player. And the way you can check that is by running git branch again. And now this third branch should be highlighted, animating the player. Okay, yeah. So if you got all of that working, you're good. You're like, fine, you're set for this workshop. And if you then open the project in VS Code, you run npm install if you haven't already, and npm start, you should see a working project with like a robot that you can move. And now we're going to go over how to do it with GitHub Desktop if these command line prompts did not work for you. So that means your Git in your terminal or command line or whatever was being a little weird. So you decided to use GitHub Desktop. And it's slightly easier because it's all like done through a UI. So the first thing you want to do is clone this repository if you haven't already. If you already did it through the command line, you should be fine. So I'm going to open up GitHub Desktop. And then the way to clone a new repository is you can click this little tab up here and click add and clone a repository. So if I want to clone a repository by the URL, I can just paste it in and it'll automatically put it in this folder called BP game dev starter after the name of the repository. Right now it's yelling at me because I already have this repository cloned, but if I just give it a different folder name, it'll let me clone it again. But I don't want to clone it again because I already have this project. So for the purposes of this, I won't be cloning it. But if you just go to, once again, this button on the top left panel and you click add, you should be able to clone the repository. Okay, and then the next thing you want to do is to change your branch. So on GitHub Desktop, this is like incredibly easy. There's this big section in the middle called current branch. If you just click it, you can easily switch between branches. So you're going to start off at this branch 00 initial game. You can just type in 03, find the third branch, and then click and switch to it. So yeah, that should be how it works for GitHub Desktop. And then if this is your first time cloning it, you want to make sure to run npm install if you haven't. And this will just download all the dependencies. npm install you have to run through the terminal. There's not really like a desktop UI that you can use for this. So you have to make sure that at least npm works in your terminal. So if you've installed Node.js through the website, it should have put npm into your terminal. And when you run the npm commands, you should get an output that looks something like this. If it says something about vulnerabilities, don't really worry about it. That's fine. And then to start the project, you should type in npm start. And I'll also send these commands in chat again, just in case. And then, yeah, it should open up in your browser, localhost 8080. And yeah, as you can see, I have the little robot man. I can move him around. And that's how you get to this checkpoint for workshop 2. If you have any questions, again, put them in the Slido and I'll try to get to them. And I think now Kosi will start.
Okay, yeah, so we're gonna move into workshop 2, but before we do that, let's just make sure like everyone is like good on these things. So there's any questions? So a couple of questions, like when I tried cloning it, it said it couldn't find that repository. Did you try cloning it with GitHub Desktop or with the git command that you type into your terminal? Desktop. So it said it couldn't find that repository. And then did you put in, do not create any pull requests? There'll be like a button that shows like create a pull request. You don't want to do that. It's just like usually when you switch branches, that's what you do. So GitHub opens it for you. And don't have anything programmed. It's okay if you don't have anything programmed because if you follow these steps, it will get you caught up to everything that we've done so far. How do I actually run it? So when you open it in your terminal, it's actually, it might be easier if I just start sharing my screen. Hold on. Okay, share screen. Okay, yeah, so if we go to, this is my GitHub desktop right here. So let me just get it back to how it was before. So like this is where you are currently when you like just clone it for the first time. This is your initial game. And to get to where Michael is, you click 03 animating the player, because that's like Michael went through how you animate that. So you click that. And then you are at this point where you have the animating player. And to open your terminal, you go up. So in Windows, it'll be like in the actual window, but on Mac, if you go up to repository and then click open in terminal, it will open in a terminal right here. And then you just run npm install. And then it will work, and then npm start. So I don't know if that was helpful. If you got it. Okay, cool. So let's move on into the second workshop. Okay, so we've gone through animating the player. So the next big thing to talk about with game development is like physics. So we are building a platformer, right? And platformers, you know, you jump around, you fall down, and they have like general physics that's like there's gravity and there's like velocities and you move forward, right? Like but so far we've just like moved the player around the screen, but like we want more than that. We want them to be able to jump and we want them to be able to fall down. So for that, we need physics. So the first thing to understand about physics with Phaser is there's this concept of a dynamic body. So like physical objects in the game are modeled with these things called dynamic bodies. which are things like code that Phaser has put in before to be like, okay, this is how you simulate physics, right? And dynamic bodies have certain properties that we'll be able to program. So things like position. So their position is represented by like an XY coordinate or a vector, which is basically tells is like, okay, relative to the whole world, here is where my player is standing. They also have things like velocity. So we'll see is like when you go right, what will happen is we will basically add a velocity to the player and they will start moving to the right, or like if we hit left, we'll add a velocity so they start moving to the left. Another thing is acceleration and gravity. So like we will have it so they fall down automatically. Well, not automatically, like we'll program the gravity in, but like they will fall down according to that. There are things like restitution. So like the bounciness of the player, we will add a thing in where like when the player hits the ground, they will like do a little hop. So that's like their bounciness. There's also things like rotation. We're not going to really be dealing with that, but that is possible with Phaser. And then the next thing is now that we have our dynamic bodies in the world, right? We have like different objects. So for example, like a player is a dynamic body. Enemies, when we code them in, will be dynamic bodies. The collectibles will be dynamic bodies. So like the thing is we need another thing that describes the rules of how they interact. So those are things called colliders. So in Phaser, a collider essentially says, okay, this object, so like for example, our player, and then these types of object or this other object, like let's say enemy or like a group of enemies, when they intersect, run this code. And that's essentially what a collider does. So yeah, there's collisions between individual bodies, which is like, okay, a player is like intersecting with an enemy. But because our enemy code, because there's like multiple enemies on the stage, it would actually be more useful to have it be a thing called a group. So there are dynamic body groups. Excuse me, can you please mute your mic? I can't see it because the current view, but that'd be helpful. Thank you. So another thing is, yeah, there's collision between individual objects and there's also collision between groups. So like you can have a player intersect with something called an enemy group. So that was like kind of a high level overview, kind of general overview of how physics works. So let's like start talking about like specifics. So if we go into our, oh yes, okay. So right now, we are in branch 3 animating the player. So if I want to open my text editor and start coding, I click open in Visual Studio Code, right? Okay. So we can go to this SRC, and we want to basically modify the player so they have physics. So if we go to components, player, so this is the player class that Michael created last time. We want to essentially have them fall down. So right now we have set allow gravity to be false. So if we comment out this line like that, and we save, we'll notice that the player will start falling if I go here. And by the way I like I have the code running here, just to reiterate it, even though we've said it already, is the way I ran it is I go to my terminal, right? My window is my windows are freaking out right now. Sorry, hold on. But yeah, so like if I stop this, the way I got that running is if I typed npm start, and it will start the like development server, which is like a thing that updates your code as you're coding, so you don't have to like keep reloading the page. So you start the development server, and it's still starting up. That's why it's hanging. But once that happens, we'll be able to go to localhost 8080 and run our code. So yeah, here's localhost 8080. I'm opening another one. Okay, while I'm waiting for this to load, let me read some questions from the chat. Okay, does it seem like there are any questions or Annie's answered them? So yeah, you notice our player is actually very slowly falling because we've added gravity back in. But our gravity value is really low. I think the default one is like 10 or something. It's like super low. So to make the player fall faster, if we go back to our code and we add like a const. So the reason why I'm adding a const here is because this is like something that's not going to be changing with the program. And it's just good to like declare things that are constant. So let me make const gravity. Oh, I'm sorry. Let me zoom in more. Is it better? Is it more visible? Okay, so const gravity, and let's make it like 350. So the player falls faster. And in this create properties method that we made here in our player class, let's add this dot body dot set gravity y. So basically what this code is doing is it's looking at, so player extends a thing called sprite, and sprite has a property called this dot body. And that's like the physics body. And we're basically setting its gravity to be gravity. Now this might actually need it to be negative, I don't remember, but if I reload my web page. You're still falling slowly. Oh, sorry. Okay, the reason why is not actually because of gravity. It's my fault. The reason why is because in our update, we are essentially setting their y velocity to 0. So if we just get rid of this, the player should now have gravity. See, look, yeah, now our player falls. And we can go back up again and it can fall, but we don't really want this. Like if I'm just holding up and the player's just like floating, he's like levitating, ascending. That's not really like the behavior that we want. So a good way to change this is instead of when we press up to just like add velocity to our player, is to instead just like check if they are on the ground, and when they press up, apply a velocity, and then otherwise like don't do anything. Because what we're doing here is we're essentially like every single time our code updates, so like every single frame of the game, it essentially increases the velocity. Are there any questions so far on like any terms that I've used that like maybe confusing, maybe, or is it pretty straightforward? Okay, so I guess I will move on then. So a way to fix this is to eventually just like say, okay, delete this. So this code, it basically checks is like if the up key is down, right? Set the velocity to be negative base speed. Otherwise, if it is down, set it to be positive, because the way that Phaser handles directions is the pause as you increase your y direction, you go down. It's like kind of the opposite of like in math class when you have like a coordinate system where it's like the y-axis goes up and the x-axis goes to the right. Here it's the x-axis goes to the right and the y-axis goes down. So that's why this we want it to be negative here. So if we save it, also I want to add in like a special jump velocity variable because I don't actually want it to be the same as base speed. So let me just make this like make this like 260. Hold on. So negative jump velocity. Okay. So we go back. So yeah. Oh, I also didn't do the check that I told us that said we were gonna do is we should also check if the body is on the floor. So there's like an on floor method that's on the physics body that the Phaser developers have included for us that allows us to check if things are on the floor. So restart the code. So now we notice I can't hold up anymore and player jumps. So that's kind of physics in a nutshell. So just to make sure that like the code that is the next step is synced up with the code I currently have, I'm going to go back to GitHub desktop and I'm going to move to the next step, which is physics. And okay, so yeah, this is good that this popped up here. So when you guys are moving to the next step, you might get a prompt like this that says like, you have changes on this branch. What would you like to do with them? You can hit bring my changes to the new one, which is like if you added something custom that we didn't like discuss and you want to like keep that functionality as you move step to step, you can do this and try to figure it out. But here I'm just gonna say leave my changes because I actually want to just like take the changes in the new branch. So if I switch to step 4 physics, so this is after we went into physics. Let's just see like if there's any, I think there's gonna be, it's a little different. I think I made the jump velocity different. So yeah, he jumps a little higher now, but like, if you move your code to 4, it should be where you are. Did that make sense? Are there any questions before I move on? What's the command for the physics one? Oh, the git command. So if you want to use the git command line, yes, the attendance form is the same as workshop one. Let me link the attendance form now. So, okay, Annie will link it. Are you also linking the command? Okay. What was the last if condition you made? I essentially check, because if we think about it logically, right? We only want the player to jump while they're on the ground. We don't want them to have like a triple, quadruple, infinite, whatever jump. We only want them to have like a normal jump. So essentially we check if they're on the floor of so on floor basically checks if the bottom half of the dynamic body is intersecting with anything. And then if that's true, then we just, if that's true and also up is down, it sets a y velocity. Hopefully that made sense. Yeah. Are there any questions on Slido? Okay, so I will move on. So the next part is we are going to talk about something called a tile map. So tile maps. But okay, before we talk about tile maps, let's talk about what a tile is, right? Because that's like the first part of the word, tile maps. So a tile is essentially in retro style games, and even like modern games use this too, especially 2D games, is it's easier to basically make your level if you have like smaller composable pieces that you can put together and build out your level that way. So a tile is just like a small image, basically, that's like a 32, typically it's like 32 by 32 pixels or 64 by 64. Usually they're square. And they're just anything that can be tessellated. So what that means is like you can arrange them in a grid, essentially. And also there are some games that use non-square tiles. So a common one is like people like to use hexagons, especially for like strategy games and like RTS, things like that. I know that's used a lot, or in some games. And tile maps allow you, or sorry, not tile maps, tiles allow you to basically reuse art throughout the game because it's just like a small 32 by 32 pixel. So I think it's, instead of me just talking about it, I think it's easier for me to show you like what an example is. So if I open up tile sets, oh, by the way I got, so I hitting on Mac, it's Command P to open up this like little window up here. On Windows, I think it's Control P. But if you hit this, it will let you search for whatever files are in here. So I'm going to search for tile sets, this one. So, okay, it's loading a VS Code. But like, this is what a tile set looks like. And essentially a tile set is a collection of tiles. And usually they're thematically related and you can have multiple of them in your game. So this tile set, we have these tiles. There's like this one that's like a brick type tile. There's like the wood one. There's like, I don't even know if these are like green stones. There's these grass, but you can just see it's like just an image of like what the tiles we use in our game are. And the thing about these images, it's not really easy to see here, but like if you were to chop them up into a 32 by 32 pixel grid, each one of these squares fits in there. So it's easy to reuse it. So yeah. A good analogy to make for a tile set is like in workshop 1, Michael went over sprite sheets / like texture atlases. They're essentially texture atlases of tiles is what a tile set is. So next, what is a tile map? So after we talk about tiles and tile sets, which are collections of tiles, what is a tile map? A tile map is just a grid of tiles, and they also have like some metadata associated with them. So what I mean by metadata is like extra information. So it might have information like, okay, here we want to put an enemy here. That's not like something you can represent with a tile because tiles are like visual, but that's like something that like your code would read and place an enemy in like a position. Tile maps are usually used to represent levels because it's easy to design levels that way. And yeah, tile maps can have multiple tile sets, and tile maps can also have multiple layers of tiles. So they're essentially grids of tiles, but they're layered, similar to like how you can layer images in Photoshop. So the way you make tile maps is you use there's multiple programs that do this, but a really popular one that is used a lot and you'll find resources for online is one called Tiled. So this is Tiled. So let me just close this. And so when you open Tiled, it looks like this. Oh, by the way, did everyone install Tiled? It's okay if you don't, because like we're just going to show you how to do it. You don't really have to, because we already have mid levels made. But yeah, okay, perfect. So if you have Tiled here, and let's just open the tile map that we already created. So if you hit open file, and my Mac is very slow, so I have like an old MacBook Air, so it lags a lot. And if you hit, oh yeah, yes, okay, yes. So so here, this is our like BP22 game dev dash starter folder. So if we go to SRC and assets, and then go to tile maps, you'll see there's these two files. There's o1.json and there's o2.json. These files are essentially like our tile maps that we've already made. So let me just open o2.json because I don't want to edit o1. But here you can see like this is what the program looks like, right? There is like a thing in the middle that is like your tile map. There's a window on the left that are properties. It's not really that important, but it just like tells you information about the tile map. And in the top right, there is these layers. So like for here, I only have a foreground layer for this map. And bottom right is like the tile sets. So when you open it, it'll look like this. But like if you're making a new tile map, this stuff won't be here. And I think I'll show that after I just like explain more of this. But essentially, we can take our tile sets here, and you can see I can select them by just left clicking over them and dragging. So let's say like I want to make like a wall here, right? In our tile map, I can just select this center one right here.
They don't have the tile sets open in the tile
program. I'm getting comments, or apparently there's questions about you're not seeing the tile sets here. So let me just re-import this to show you what it looks like. So if I hit trash, if you do have this open, if you hit trash, oh wait, I kind of don't want to do that. Okay, it's fine. You know, let's just delete, let's just like make this like it looks like when you have it originally. So let me just delete this, right? And it'll look more like this. So if you hit new tile set, and then you hit browse, right? And we open, so here we're in our assets folder, and we're going to tile sets 01 .png. So we open that, right? And we just want to name it 01. This is a good name. And the tile width should be 32 pixels by 32 pixels, the width and height. And we hit OK. Hit OK. It re-imports it for us. So let's make a new layer in our tile map called, it was called foreground before, so I'm just gonna call foreground again. And let's like make just a simple ground, right? So if we select this tile here and in the top bar, I'm clicking on the fourth icon from the stamp one. So this rectangle that's next to the paint bucket and the eraser. And we just like, we can just draw a tile like this, right? We can just draw a ground. And like, I mean, this is okay. Like it's all like kind of the same color, but like we want it to have more variety, right? So the thing is, you can see like usually tiles that are related, if like whoever created the tile set is like sane, right? They will put like associated tiles close to it. So for like, you can see this one's like a top left corner. So let's put that there. This one's like a top right corner. This one's like a bottom right corner. So let's put on the bottom right of the platform. And this is like a bottom left one, right? And we can take this one that is supposed to go between the top right corner and the bottom left corner and just like paint that. And then do like that. And then do this. Uh-oh, and then do this. And this is like we have something here, right? We're like getting started. Like this is what our tile map looks like. So if I hit save, it will essentially save it in o2.json. So like we've already made a tile map. We can make more complex ones later. But let's like actually start and like import it and like start using it in our game, right? So if we go back into VS Code, so give me one second. So if I go into if I open up my sidebar again, so I click this icon on the top left. Let's go back to our scenes, main scene.js, right? And essentially, first thing we need to do is we need to load it into our game. So this preload function, Michael talked about it, but what this preload function does is it actually loads our assets from our file system. So it like looks at the PNG files and like the .json files, and it actually puts it into our game because by default, they're not in our game, right? So before we like actually put our tile map, okay, we have to load it. So let's say this code loads the tile map. So we do this dot load dot tile map. You see this code gives us a completion here, tile map tile JSON, right? And if I start completing it, it needs a key, which is like what we will call the asset in our game. So we give it a string. Let's just say this is tile map 01. Or let's load an O2, the one we just made. And then you give it our URL. So we have to import it up here. So we import tile map 02 from assets / tile map / I think, o2.json gives us completion here. Load in tile map 02. And let's see what other arguments is it asking us for. I think that's it. Okay, so we load in the tile map. We also have to load in the tile set because the tile map is a different file from the tile set. So let's also import our tile set. I think it's called tile set 01. So I think it's just .png. So what I wrote here is I did import tile set 01 from /assets / tile set / 01.png. And so let's do this .load .tile set. No, sorry, no, it's .image because it's just an image, right? So like Phaser's reusing the code for that. So it's, oh, should I put the imports in chat? I will do that. So these are the imports. Let me open up chat. Okay, hopefully that's helpful. Also, if you do miss this code and like, you know, I do type somewhat fast. So if you miss this code, remember you can always just go to the next step once we do this. So where was I? So yeah, we're loading in tile set 1 from tile set 1. So we've loaded in this code now. Now we will need to create the map. So I'm going to make a helper function here above our create called create tile map. And what this code will do is it will first create the map. So like const map equals this dot make dot tile map. So this is how you like actually start making the tile map in your code. And it takes an object that's like a key, which is like the name of the tile map, which we called -02, right? And so now that we have our map imported, we actually have to, by default, Phaser doesn't let you just like import the tile map and it works, right? You have to import like every single layer, and like you have to individually draw it. So let's, if we go back to tiled, right? We saw that we made a foreground layer. So let's import that. So we do const layer 1 equals this dot, or it's equal to map dot create layer. If VS Code will give me code completion, thank you. Create layer, and then we give it the layer ID. So we called it foreground, and we also give it the tile set, which is tile set 01. Okay, and let me actually not call this layer 1. Let me give it a better name, foreground. And next, what we have to do is we have to, let's just return it from this function, right? Let's return an object that has map in it and foreground in it. Yes, and then in our create function, let's just say loads in tile map. This comment, because comments are helpful. This dot tile map equals create tile map. Let's see what, or it's this dot create tile map, because right, we put this function in our class, so we have to refer to it with this dot. Let's go to lookups 8080. Okay, good. This is a good exercise in debugging, because none of us write perfect code, right? So a good way to debug stuff is opening this thing. So if we hit inspect, I just hit right click inspect. It opens up this thing, which is a like a developer tools, it's called. And we open our console. So it says uncaught type error, this dot reate tile map is not a function. So we know reate tile map is not a function. So that means we probably misspelled it. We probably misspelled it. It doesn't look misspelt. So sometimes when you just reload the page, stuff works. So yeah, reloaded it. Okay, and we don't see our tile map, which is interesting. We don't see our tile map. Okay, that's fine. So let's let me just quickly look at, or this is actually a good exercise to show you. So in GitHub Desktop, a useful thing is like you want to look at the difference between two branches. So let's look at the difference between our current branch and the next branch. So to do that, we hit branch and we hit compare to branch. And we want to compare our current branch, which is 4, to branch number 5, which is tile maps. And then maybe we can see like, well, I need to check what I am forgetting with tile maps, and then I explain it. But like this could be useful elsewhere to just see normally. So in tile maps, it looks like the big thing we're missing is, oh, did I not? Oh, yes, that's true. I forgot to add the tile. So yeah, you have to explicitly add the tile set image. So you have to do map dot add tile set image. And it takes in a tile set name, which I think we call tile set 01. Oh, no. Sorry, this name, this tile set name corresponds to what the name of the tile set is in tiled. So it's 01. So we put in 01 tile set 01, right? And we could call this variable tile set. And then we actually are supposed to use this variable here in foreground.
Oh yeah, just to clarify, the reason we used 01 in quotes is that in our tile map, we labeled our tile set 01. So this piece of code is just telling us that the O1 tile set that our map is referring to can be found in the image that we gave it in the second part, which is called tile set O1.
Yeah, exactly. Thank you, Annie. So another thing is with create layer, you also have to give it an X and Y position because like, okay, where do I draw it relative to the screen? So let me say 0, 0. So it knows to like, just so it's in like the correct position. So if we go here and reload, it says invalid tile set image. So that means we probably made a typo somewhere. It's not load image, tile set 01, tile set 01. Okay. Tile set 01, tile set 01. I'm not, oh yes, because this is tile set 01. Yes, that's supposed to be a string. Because what this line 33 here is saying, okay, create a tile set from, call it, so the first one is like what it's called in tiled, which is 01. And then the second one is like what the name of the asset is. So up here we called it tile set dash 01 slash, sorry, not dash, that's a slash 01. Okay, so there's no more errors. What I think is happening here is that it's actually drawing, but you can't see it because of the camera. So I'm actually going to add more code in. I'm going to explain how cameras work later, but I'm going to add this code in called this.cameras.main. So this main camera is like a camera that is looking at the like camera that's like basically displaying this. And essentially what a camera is, it's like a viewport of your world because you can't see your entire game screen at one time, right? If you've ever played like any platformers or like most like action or adventure games, you know that there's like another world that's outside of your screen. So that's essentially what a camera is. It's just like a viewport or like a whole or like a lens you look at, like just like a part of the world. That's essentially what a camera is, but I'll go into more detail later. So let's say this.cameras.main dot start follow this.player. So what this code does is it essentially tells Phaser to like move the camera so it looks at the player. So let's look at this. So now as we're following, it's following the player and we can actually see, yeah, look, it actually is drawing our tile set, but it's like, it was like, we were too high up to see it. So like that's working now, but now there's like another weird bug, right? That like, wow, we like, for some reason, like we stop here and like, we can only go all the way to the left and like, everything is stopped. It's like really wonk, right? So the way we fix what's essentially happening here is if we go back to our player class, we earlier said, or Michael earlier said that he wrote this code here that's like this dot set collide world bounds true. So by default, what Phaser will do is it will draw the world bounds where the camera is initially. The camera is moving, so like it's moving past the world bounds, but essentially we want to set the world bounds to be basically where the tile map is, right? So we can just add a line of code. It's like this dot physics dot world dot, what is the name of the function? Is it set bounds? Yeah, set bounds. And here is asking us for like an X, a Y, a width, and a height, and then like some other ones that we don't really care about because they're optional. But we basically want this will like, it's asking us for a rectangle, essentially that's like defined by XY, which is like the top left corner, and then the width and height of like where we want the world bounds to be. So we're gonna set it to 0, 0, which is the top left of the world. And the width is this dot tile map dot map. Because remember, we returned an object up here that's like map. Oh, by the way, like if you this is essentially what we did here, but like I used a shorthand that I didn't explain. So we're making a new JavaScript object here that's like key is map, values map, key is foreground, values foreground. So we set the bounds and we want it to be tile.map dot oof, I did not want VS Code to do that. Don't be bad. Width in pixels, yes, and then this tile map dot height in pixels. And it's going off screen a little bit, or at least for me. So I'm just going to add some indentation. And and I formatted it. And how I did that is I pressed Option Shift F, but like you can just, yeah, I just hit Option Shift F on Mac. I don't know what it is on Windows. Probably like Control Shift F or like Alt Shift F, but it doesn't really matter that much. But this is just like, I just like you can format code. So let me save that, and it should move the world bounds. So yeah, this is better, but like, essentially another thing is we want our background to stay constant, because you can see like our background is like we're like moving on different parts of the background, and like we can see outside the world, like this black box here is like the area outside the world, which is kind of ugly, not gonna lie. So the way we can fix the background image, wrong tab, sorry. The way we can fix that is by doing this dot background, because remember we made the background in workshop 1. So this dot background dot set scroll, because set scroll factor would, and what this is basically saying is like this image relative to how the camera is moving, how much do we scroll it? And we just say don't scroll it at all. So it will make our background not move. So if we reload that, we'll notice our background does not move. So our background stays the same. But another issue is like we are just falling through this tile map, right? And we're colliding with the world bounds, just like the bottom. That is not what we want. We want to essentially have physics and collide with this tile set. So the way we do that is if we go back here, we have to essentially tell Phaser, okay, make sure enable collisions so first of all, for each layer, we have to enable collisions. And then we also have to add a collider between that layer and the objects that we want to collide between them. That was kind of a mouthful and kind of abstract. So if that's confusing, just ask. Let me check. Yeah. So what we can do here is do foreground dot set collision collision by exclusion. So what this function does is it essentially tells tile to turn on collisions for every single entity, or sorry, for every single tile. I don't know, I said the word entity. It tells Phaser to turn on collision for every single entity. Sorry, I said it again, for a tile based on like array we pass in that, like if it's not that index. So we put in -1, and this essentially turns on collisions. And like to explain that more in depth is like, if we notice, we go back to Phaser tiled, I'm mixing up everything. Is if we look at our tiles and I click on them, you can notice in like the top left, each tile has like an ID, right? So like this one is ID 0, ID 1, 2, 3, and they're like all non-negative integers essentially. And since -1 is a negative integer, it will essentially turn on collisions for every single tile in this foreground layer. So that's step 1. Another thing is we have to make a collider. Let's do this dot collider, or sorry, this dot physics. So we're telling physics to add dot collider. And we want to make a collider between this dot player and this dot tile map. Dot map, or sorry, tile map dot foreground, I think, because we want them to intersect with the foreground layer. So if we reload, now we can see that, yeah, we intersected the ground properly. So there's like one last thing before we like field it to questions, and I think we're editing towards the workshop, so we'll probably just answer questions and then leave it there. But one last thing that's here is, as you know, if we go towards the left, it kind of like goes off the edge of the world, and we don't really want that to happen. So the way we can do that is by adding boundaries to our camera. So if I go back here, and then I do this dot cameras. Let me actually, okay, let me put this code up here. So it's like all the camera code is together and all the background code is together. I'm just moving around stuff. So if we want to do this dot cameras dot bounds, no, this dot cameras dot main dot set bounds, which is similar to the world set bounds, right? And we just want it to be the same. Okay. Okay, save. Now, if we go back to our game, we'll notice that the camera won't move past the like boundary of our world, which is what we want. So yeah, if I move to the left, the camera no longer goes off the side of the screen. If I move to the right, yeah. Yeah, so that's kind of tile maps. I'm gonna talk about cameras and then we will move towards the conclusion of this workshop. So if we go back to my slides, so camera. So what is a camera? There's an image at the bottom right. It's kind of small. Let me see if I can open it to be bigger. I don't think I can. Maybe if I zoom in my browser. Like this is a pretty good, yeah, it's not working that way. Uh-oh. Everything is zooming in. Okay. I guess let me just describe the image since it's kind of small. There's like the larger gray rectangle, which is like kind of the represents your world. And you can see there's like a smaller white square rectangle. That is essentially like the camera. And what is happening? So like the camera is basically occluding / cutting out anything that's like not in that square. So that's like the only thing you can see. And yeah, that's like how cameras work. They're essentially like I said it already, but viewports / rectangles, like it's like the part of the world you can see. So technically cameras are like actually quite a lot of math to get right. So thankfully Phaser includes code for it that does it for us, because usually it has to do with like matrices and linear algebra, but we don't really care about any of that math. All we care about is that it's like a viewport / hole we can see the world through. And I guess like there are, how does a camera work? Like there are multiple types of cameras. So there's like orthographic cameras and there's perspective cameras, right? So in 2D games, we typically use orthographic cameras. So what that means is when the camera is looking at your world, it makes everything like the same size. Like it doesn't take into account how far away things are, which is why it's called, like the other one's called perspective, because objects that are like further away look smaller, objects that are closer look larger. So it takes into account perspective when scaling objects. So in 2D games, you typically use orthographic cameras, which is the one that Phaser has. Cameras can do all sorts of things. So you can like clip things. So like you can like say, okay, the camera, don't look at like these types of objects. We're not going to be doing that. You can scale cameras. So like you can make them bigger or smaller. You can rotate them and do like, yeah, you can rotate them and you can do like cool effects. Like you can zoom in, shake and flash. So yeah, that's kind of the end. I think we're kind of like the end of the workshop here.